Okay, good. So the second measure in descriptive statistics, it's a measure of variability. Okay, and under measure of variability, we only have what? Two measures. That is variance and what? Standard deviation. During the introduction or the first day, I defined variance, and I say that in layman's language, variance tries to show us how far, okay, how far that is our data points are away from the what? From the mean. Okay, then for standard deviation, it shows us now the distribution of what? The distribution of those data points, okay, away from the mean. All right. Let's see. We'll see the difference. Okay. Yes. So in terms of variance, that is in statistics, we say that variance refers to a statistical measure of the spread between what? Between numbers in a dataset. More specifically, variance measures how far each number in the set is from the mean, and that's from every other what? From every other number in the set. Okay, so basically it shows us how far each number it's away from the what? Away from the mean. Meaning if we get that is a high that is value of variance, then it means we that is our data points are spread, okay, far away, or they are away from the what? They are far away from the our mean. Okay. Yes. So variance is often depicted as sigma squared. So for we have sample data, okay, and we have population data. Okay. So for population data, uh, variance is denoted as sigma squared. Okay. Then for sample data, variance is denoted as what? As a that is as s squared. Okay, and variance is majorly used to measure that is volatility, like in market security or yeah in securities we use variance to measure what? To measure volatility. Okay, like the risk. Okay. Also, standard deviation helps us to maybe know the risk. Okay, the risk of maybe certain investment. Okay, that is in terms of financial application. Okay, yeah, standard deviation can help us maybe to know that is consistence in an that is returns, or it can help us also know the risk of the asset which you are investing in. Okay, so we are saying that it is used by both analysts and traders to determine the volatility and market security. Okay, so the square root of variance is the standard deviation, and standard deviation under population data it's given by sigma. Okay, which is the square root of what? Sigma squared. And s for sample what? For sample data. Good. So the square root of variance, we've said it is the square root of variance is the standard deviation, okay, which helps determine the consistency of an investment's return over a period of what? Over a period of time. Let's maybe see some of properties of what? Some properties of variance. So maybe according to layman's words or language, variance is the measure of how far a set of data is dispersed out from what? from their mean or from their average value, and is denoted by sigma squared, as that is for population variance. So we have properties of variance. Okay, so for the properties of variance, um, it is always non-negative. Why? Because each value, that is the difference, we usually square the difference of each value to its mean. Okay, basically we know that, let's say, let me take the variance of what? Variance of a sample what? Of a sample data. Let me just take an example. We know that sample data, okay, or the variance of a sample data is given by, let's say, x1 minus x bar squared, okay, multiply by, no, not multiply, sorry, should be sum. So this is squared, okay, plus x um, 1, okay, x1, x2, sorry, minus x bar squared, okay, plus up to xn minus what? Sorry, yeah, up to xn minus x bar into brackets squared, divide by what? Divide by n minus 1. Okay, I will give you an assignment, and I will let you know that is the assignment before we can do what? Before we can break, or we can end the class. So maybe this we can also try to, that is, make it simple by using summation. So we know that uh, sample variance is given by summation of xi's, okay, where I, it's from what? It's ranging from 1 up to maybe n minus x bar, okay, squared, divide by n minus what? N minus 1. Okay, so this is the formula for what? This is is the formula for sample variance. Okay, that's why we are saying that it is a non-negative. It is a non-negative value. Why? Because let's assume we had a mean of what? Let's assume we had a mean of 20. Okay, and our first value is 2. So it will be 2 into 2 minus 20. Okay, so the square will do what? Will make the value an absolute value. Okay, yes, it will make it an absolute value, meaning it will be like a positive or a non-negative value, because negative 19 squared, okay, definitely this negative sign will what? We will cancel out. Okay, all right. So that was just a by the way. That was just a formula. It's the mathematical formula for variance. Okay. Yes. So we were saying that it is always a negative, since each term in the in the variance sum is squared, and that's the result is either positive or 0. Okay. Yes. Then variance always has squared units. Okay, it always has squared units. So, for example, the variance of a set of weights estimated in kilograms will be given in what? Kilograms squared. Okay, so like if we do a variance of weights, then the what? The unit of variance will be what? Will be like, will let's assume it's a kilogram, then it will be kg squared. Okay, so since population variance is squared, we cannot compare it directly with the mean or the data themselves. Okay, yes, nice. Now let's go to standard deviation. Any question under variance? Any question under variance? Hello? All right. So then it means we are all good. Let's go to the last, that is measure of variability. So don't worry, maybe we will understand this value better when we'll do the practicals, because we'll also have to do what? We'll have also to explain that is those numbers which we get. Okay, so let's check on standard deviation. Standard deviation. So standard deviation is a statistic. Okay. So we've said standard deviation is square root of what? Is square root of variance. It's a square root of variance. So let's assume we have variance that is, as we said, summation of xi's, okay, minus x bar squared divide by n minus 2, 1. Okay, so we need what? Standard deviation. So standard deviation will be simply the square root of this. Okay, the square root of this will be what? Our standard deviation. So standard deviation is a statistic that measures the dispersion of a data set relative to its mean, and it is calculated at the square root of what? Of variance. The standard deviation is calculated as the square root of variance by determining each data point's deviation relative to the what? Relative to the mean. That's why you can see we are minusing what? We are minusing the mean. Why? Because we are trying to determine the distance between that is each data point to the what? To the mean. So if the data points are further from the mean, then we will have what? Higher deviation within the data set. That's the data set will be more spread out, and in this case we'll have what? A higher standard deviation. Okay, in this case we'll have a higher standard deviation. Okay, so we've said that the spread of statistical data is measured by what? Is measured by standard deviation. Distribution measures the deviation of data from its mean or average position. The degree of dispersion is computed by the method of estimating the deviation of the data points, and it is the standard deviation is denoted as what? Sigma. For what? For population data. Then we have some properties of standard deviation. So standard deviation describes the square root of the mean as the squares of all the values in the data set, and is also called as the square, or it's also known as the root mean square deviation, that is RMS, the root mean squared deviation. Okay, yes. And if maybe we have someone with machine learning, that is machine learning, uh, machine learning knowledge, I know you've ever came across what? The root mean square, also the mean square. When more so we are what? We are optimizing the accuracy, okay? Or we are measuring the accuracy of that is of a predictive model, okay? Yes, I guess this will also be covered during that is machine learning session. Okay, so the smallest value of standard deviation is 0, and it cannot be what? Negative. The same to what? Same to variance. We say the variance is what? Is a non-negative in nature. So when the data values of a group are similar, then standard deviation will be what? Very low or close to 0. Why? Because we don't have major deviation that is within what? Within the data points of that certain maybe group. Okay? But when the data that is values vary from with each other, then the standard deviation or variation will be what? Will be high or will be far away from 0. And now we have now the formulas. Okay, we have the formulas for these two measures of variability. So we have that is under population, and we have under what? Under sample data. Okay, so we have variance and population. Okay, here we have the same formula, but here we are now minusing with mu because it's population, but we are dividing by what? We are dividing by capital N. Capital N representing what? Representing population. Okay. Then when it comes to standard deviation, is the square root of the above. Okay. Now when it comes to that is to sample data, I had already illustrated this. Okay. Then the standard deviation will be what? Will be square root of what? Will be square root of the above. Okay, then my takeaway question. Why are we using capital N, that is only N, under population, but under sample, we are using N minus what? N minus 1. Food of thought. Okay, you can go and research more. Why are we using capital N in population and we are using, maybe we are using, let's say, N. Of course, it is capital. And under sample mean, our sample size, we are what? We are minusing 1. Okay. Why can't it be also n minus what? N minus 1 under the population. Okay. That is a food of thought. You can go and do what? And research more on that. And that marks the end of my